So, after getting much knowledge about the diagram of the sulfuric acid, here we are going to talk the reactions involved between the preparation of the sulfuric acid. So, the SO2 produced is purified by removing dust and other impurities such as arsenic is here. Here is the arsenic compounds can be absorbed out that we have talked about flow chart. The key step in the manufacture of sulfuric acid is the catalysis oxidation of SO2 with O2 to get the SO3. So it should be 3. Yeah, 3 આવશે that you have to keep in mind. By mistaken લખાયું નથી. So this is 3. SO3. Okay. So SO3 in the presence of vanadium pentoxide, and this is the reaction. Sulfur dioxide in presence of oxygen in presence of vanadium pentoxide gives sulfur dioxide. Now this reaction is minus sign. See, this is the minus sign, and as it is minus, reaction is exothermic, and if reaction is exothermic, then we will have a process. Okay, so now what is the different idea about the process that we are going to look out in the next slide? Come on. The reaction is exothermic, reversible, and the forward reaction lead to decrease in volume. હવે આપણે આ જાણીએ છીએ કે કોઈ પણ રિએક્શન હોય તો પેસેજ ઓફ ટાઈમ ટેમ્પરેચર ઇન્ક્રીઝ થતા બેકવર્ડ રિએક્શન ચાલુ થઈ જાય, અને ઇફ બેકવર્ડ રિએક્શન ઇઝ સ્ટાર્ટેડ તો ફોરવર્ડ રિએક્શનનું વોલ્યુમ ઓછું થતું જાય, and that's why પ્રોડક્ટ ઓછી થઈ જાય. So this will be the some tentative idea. So low temperature and high pressure are the favorable condition for maximum yield. અગર તમારે maximum yield જોઈતી હોય તો condition શું એપ્લાઈડ કરવાની છે? High pressure and low temperature. Low temperature and high pressure will give more idea. But the temperature should not be very low, otherwise rate of reaction will become slow. ચલો હવે આપણે ટેમ્પરેચર લો કરવા માટે ટેમ્પરેચરને માઇનસમાં લઈ જઈએ, કેવું ફાયદો? 0 કેલ્વિનના નજીક લઈ જઈએ તો કેટલું મસ્ત થઈ જાય. ચાલશે આવું? ના. અગર ટેમ્પરેચર જો લો થઈ જાય તો જે એટમ્સ છે એની મુવમેન્ટ જ ના થાય, અને એટમ્સની મુવમેન્ટ સ્લો થઈ જાય. ધેટ ઇઝ ધ અનધર પ્રોબ્લેમ. એટલે આપણે એક બાજુ ટેમ્પરેચરને વધારે ઘટાડવાનું પણ છે, એટલું પણ ઘટાડી નહીં દેવાનું કે જેથી થઈ જાય. ઓકે, સો the plant is operated and the temperature 720 Kelvin. The gas is absorbed in concentrated H2SO4 to become. Now here for everyone, actually this is the reaction Joe. H2O, okay, plus SO3, okay, H2O plus SO3 કરીએ, so it can give us sulfuric acid. Now this produce sulfuric acid is very easy. ખાલી પાણી સાથે રિએક્શન કરાવી દો, સલ્ફ્યુરિક એસિડ મળી જાય. તો આ ધંધા કરવાની જે જરૂર છે કે it is absorbed into the sulfuric acid જે આગળનો બતાવેલો છે તેવો. ઓકે, એસિડને એબ્સોર્બ કરીને એમાંથી શું બનાવવામાં આવે છે? ઓલિયમ. તો ઓલિયમ ઇઝ પ્રિપેર. ઓલિયમની ફોર્મ્યુલા શું છે? H2S2. આ કામ કરવાની જરૂર શું કામ છે? Because the reaction of H2O plus SO3 is exothermic reaction and lots of amount of heat is produced during these reactions. આ રિએક્શનના દરમિયાન lots of amount of heat is produced, અને એટલી બધી હીટ હોય કે એ વેસલ્સને બ્લાસ્ટ પણ કરી શકે, and that is very dangerous scenario, and that's why it is important that કે સલ્ફર ટ્રાયોક્સાઇડનું રિએક્શન વોટરમાં નહીં કરાવીએ તો પ્રોબ્લેમ થાય, and that's why we are going to take absorb it into the sulfuric acid to get H2H2O7. Now H2H2O7 ની અંદર તમે પાણી નાખો. If you will water into H2S2O7 એમાં તમે એડ પાણી કરો તો automatically that will give you 2 times sulfuric acid. 2 times sulfuric acid. It will give 2 times sulfuric acid. Now બોલો કયું બેનિફિશિયલ છે તો એને પહેલા એ બનાવ્યું. હવે તમને અહીંયા જે કોન્સન્ટ્રેશન વાળું સલ્ફ્યુરિક એસિડ જોઈએ એટલું પાણી નાખો એટલું સલ્ફ્યુરિક એસિડ બની જાય. એન્ડ અપ ટુ વી કેન પ્રિપેર, see here, we can prepare up to 98% of sulfuric acid, and that's why this is the important. So the gas from the catalysis converted is absorbed into the concentrated H2SO4 to produce oleum. Dilute of the oleum with the water is giving H2SO4 of the desired concentrated. In industries, 2 steps are carried out simultaneous and one at also to reduce the cost. Sulfur dioxide is okay. So this will be our idea, and here battery પતી જાય છે એવું લાગે છે. So we will continue. Okay, so this is the process where we can make sulfuric acid. Okay, now in next of the properties. Okay, sulfuric acid is colorless, dense, oily liquid with the specific gravity of 1.84 at 298 Kelvin. That is the information. The acid freezes at 283 Kelvin, that freezing point, and boils at 611. That is the boiling point. Okay, so these are the information where its melting point and boiling points are given. This is the melting point and this is the boiling point of the sulfuric acid. Okay, it dissolves in water with the evolution of large quantity of heat. Hence, care must be taken while preparing sulfuric acid solution from concentrated sulfuric acid. The concentrated acid must be added slowly into water with the containing stirring nitroblast. So that is now the nascent industrial strain can be judged by the quantity of the sulfuric acid it produces and consumes. It is needed for the manufacture of the hundreds of other compounds and also in many industrial process. So this is our knowledge about the sulfuric acid. Sulfuric acid can be used multi-purpose. In many ways we can use the sulfuric acid, and sulfuric acid is the main parameter of the growth of the nation, industrial growth of the nation. That's why the sulfuric acid is important. Now this is the top. Now here above this, how can we go, that I am going to talk you. The bulk sulfuric acid produced is used the manufacture of fertilizing of ammonium sulfate and superphosphate. These are the fertilizers. So majority fertilizers are obtained from the sulfuric acid. That is the one another part which we have to consider out. Other uses are, and now this is the area where sulfuric acid can be used up. The first area in the petroleum refining. So in petroleum refining, when sulfuric acid is used, at that time it is used as oxidizing agent in manufacturing of the pigments, paints, and dye stuff, intermediates, etc. So dye stuff intermediates means what? જે કલર છે ને બધા એ કલરના બેઝિક મટીરિયલ છે એ કલર બનવા માટેના, that depends on the, that's why the sulfuric acid is important stuff for. Now next point is detergent industry. Sulfuric acid is the widely used to get the NaOH, more amount of NaOH from the, that is also the detergent industries. Metallurgy application you can say about the cleaning, it is enameling or color કરવાનું છે, galvanize કરવાનું. એટલે આપણે કોને યુઝ કરી શકીએ છીએ? સલ્ફ્યુરિક એસિડને યુઝ કરી શકીએ. સ્ટોરેજ have studied in lesson number 3 કે સ્ટોરેજ બેટિંગ મેઇન વસ્તુ છે in the manufacture of the nitro laboratory reagents. So these are the working area of the sulfuric acid. Hope that sulfuric acid's will be very important for you and you are studying that nicely. So with that, the sulfuric acid and its uses, properties, and that all. So now it is time of evolution of your cell. So come on dear, check out the self evolution. Okay. So here first question is the oxides of sulfur shows paramagnetic behavior. Why? So why this is behaving as a paramagnetic that we have studied earlier. Okay, it become like oxygen, and when it's S2 combines at that time, uh, though it is pairing out, sulfur converts into the having unpaired electron due to the bonding. Okay, when sulfur dioxide is passed through the aqueous solution of Fe3, is reduced out to Fe2. Fe2SO, FeSO4 is produced. Uh, Comment on the nature of the two SO bonds formed in SO2 molecules. Are the two SO equal? No, not equals. Yeah, not equals. Single bond હશે અને ત્યાં double bond છે ત્યાં એની bond length ટૂંકી થઈ ગયેલી હોય. How is the presence of it is reactive with the potassium permanganate? Then they શું કરે છે potassium permanganate નું reduction કરીને એને MnO4 minus આવે છે જે MnO2 colorless છે. So that is the idea. Violet colorless, in which H2SO4 plays an important role. So that you have to write the condition for the max CI4, and that is nothing but when industrial unit is working, that we have to check. Ka1 and Ka2 are equal for H2SO4 in, because it both the time same amount of water is used out. Okay, so these are our idea sulfuric acid and its question. So hope entirely, and you will write this thing in a. Okay, so first question is back. So which form of sulfur shows paramagnetic behavior and why?